So hi there, this is Shrikant Sare. So in this lesson, we are going to learn about the increment operators, whether it is a postfix or prefix. And so in the previous tutorial, I have made a small lesson which includes how the increment operator works. Okay, so there the result is so if you take an expression something like this, if I'm taking something like this, a is equal to 10, and if I take a variable b, and if I build if I build a small expression like this, okay, so if I say something like this, plus plus a plus a plus a, okay, so this the result of this expression is going to be 39 in my compiler. Okay, in my compiler, here I'm using a Visual Studio. Okay, so if you execute this program, uh, so the answer is 39. Okay, so the people got very confused. The results are very pretty inconsistent. They vary from one compiler to one compiler and from one language to another language. Okay, so if you do this, if you execute the same piece of code, so in my system, I have installed Turbo C++ as well. Okay, so which is a bit older compiler. Okay, so the same program, if you look into the what I did in Visual Studio or Visual C++, there I have done the same thing here. So if you execute this piece of code here, the result is 36. Okay, so the language is same here. I have used C++ on both the occasions, and depending upon the compiler you are using, the results got changed. Okay, so I observed that some of the programmers or YouTube viewers had done the same piece of code in another languages like Perl or Python, or some are getting 37. Okay, so the reason is obvious here. Okay, so it all depends upon the compiler, or on which algorithm, or on which parsing tree. A lot of things are there while building the compilers. The companies think different ways. Okay, so how would they parse these statements, and how would they construct a tree, and then based on that the results will be displayed. Okay, so if I come back to the same Visual Studio once again, so if I just change the program from this way to another way. Okay, so if I do something like this, if I just change the a plus plus uh, to a plus plus. Okay, so if you observe the result of this piece of code here, the result is 30. Okay, so you might think that the result must be 33 or something like this. Okay, so if you come back to once again, if you come back to that Turbo C++, I'm just changing the prefix operator to postfix operator here. Okay, so I'm just changing the prefix operator to postfix operator, and if you see the result in Turbo C, and if you execute the program, the result here is 33. Okay, so you might think that in the thinking that initially the value of a is 10, so since it is a postfix operator, the evaluation is from left to right, and first the expression would be evaluated to 10, and actual value of a is 11, and again it's evaluated to 11, and the actual value is 12. Actual value is 12, and it gets evaluated to 12, so 12, the actual value is 13. So something you might think like this. Okay, so but the result here, it is coming as 33, and there it came as 30. Okay, so here one might think that the actual thinking is the value of, since it is a postfix increment operator, every time what happens here is here the thinking is that the value of a is already, since it's a postfix operator, the value retains 10. Okay, because the compiler, the basic thinking of us would be something like this. Okay, so if we think that a is equal to a plus 1. Okay, a is equal to a plus 1, and then so keep on every time the value of a is 10, and then it might be 30 or something like this. Okay, so but that is not the case when we are using the turbo C++ there. Okay, so these are the very inconsistencies. Okay, so it all depends upon, no need to worry about the results and about the languages or the compilers. It may vary according to from compiler to compiler, from language to language. Okay, so another simple thing I'm saying here, so if we take something like this. Okay, so I'm just commenting this statement here, both the statements here, and I'm just taking a printf statement. Okay, so I'm just taking a printf statement here, percentage d percentage, I'm just saying percentage d comma a plus plus comma a plus plus. Okay, so if you execute this piece of code here. Okay, so if you execute this piece of code here, you might get excuse me, I think put some space here. Okay, so if you execute this piece of code, the answer you're getting here is 11 and then 10. Okay, so first, the reason it came here as 11 and 10, because the first and foremost, the actual value of the variable, the actual value of the variable is 10, and then it gets incremented even though it retains the value 10 and the actual incremented value is 11, and then again it goes to the next one, it gets incremented to 12, and but the actual retained value is 11. And if you think of a stack, something like a stack, the topmost value now is 11, and then first that gets popped out, and then whatever the value retained here in this side and whatever the value retained in this side is getting popped in the next 10 here. Okay, and which is 10. Okay, so for that reason it came as 11 and 10. Okay, so in this case, if you use prefix operator here, okay, the prefix operator, and if you execute this piece of code here. Okay, so what happens here is 12 and 12, because both the things are 12 and 12, because the actual value gets incremented to 11, and then it's incremented to 12. Okay, the actual value becomes 12 and it pops out both the time. Okay, so in the first instance it's 11, and the second instance it's 12, and that result got down here. Okay, so if you execute the code, you get both the results as 12 and 12. Okay, so if you do the same piece of code, if you come back to my turbo C++ here. Okay, so the very inconsistencies are there, so it's a lot of confusion to the programmers and all. So if you take this small printf statement, and if you take another percentage d here, and if you say something like this, a plus plus comma a plus plus. Okay, so if you execute this piece of code here, what happens here is the same. In the first instance, you got the result as 10, as we discussed. The first value retained is 10, and then it becomes 11, and then the actual value in the top of the stack is 11, and then the value is 10. So that's what displayed as you got the same result in the previous instance. So if you change this actually to plus plus operator here. Okay, so plus plus a and plus plus a, and if you execute the code. Okay, so if you execute the code. Okay, once, just a second, let me put this CLRS here. Okay, so if you execute the code here. Okay, so here you got 12 and 11. Okay, so actually what happens here is the first instance the value of a will be 11, and the second instance the value of a is 12, and based on the stack principle, the highest value gets popped first, which is 12, and then the next value which is stored in the stacks gets popped, which is 11. But here you got 12 and 11. If you come back to our Visual Studio, where we have the same piece of code, so if you execute this code here, you're getting 12 and 12. Okay, so quite a few inconsistencies are there within the printf statements. The increment operator works like one thing here in Visual Studio compiler, it works in a different way. The printf statement, if you use the increment operator and printf statement in another compiler like Turbo C++, it's going to take in another way based on the stack principle, and prefix works in one way and postfix works in another way. So if you have a combination of prefix and postfix, it's going to work in another different way. So here I've just changed here once again. I have first taken the plus plus operator. The initial the value of a is going to be 11, and then it retains the same value 11. Now let's see what happens here. Okay, but the answer is 12. Oh, one second. Let me close, save. Okay, so here the answer is 12 and 10. So if you come back to the if you come back to the Turbo C++, sorry, Turbo C++, and if you just make that change here, first let it be increment operator, and let's take postfix here, first prefix and then postfix, and let us see what happens here. The result is again 12 10 here. Okay, so some results are working. Let us take both as postfix operators here. 1110. Okay, so if you observe here 1110, the first instance, it works exactly the same. Okay, so plus plus, and if you execute the code, it's treating as 1210. Now you got the same result in both the compilers here. Okay, so these are the very pretty inconsistencies about with different things. And printf statement, one operator works in one way and another operator works in another way, so you need not worry about the results. You get focused, you fix to one compiler. Always it is suggestible to use the latest compiler. Here I am using Visual Studio 2005, which is the older compiler compared to the Visual Studio 2005, sorry, 2015. So always try to use or execute your code in Linux. There you get the perfect result, because always rely on the latest compilers and latest IDEs for the better results. Okay, so see you in the next lesson. Goodbye.